All right, guys, welcome to 4.6, isosceles and equilateral triangles. This should be a pretty quick lesson, so let's just get right into it. So first of all, what is an isosceles triangle? Well, an isosceles triangle is a triangle in which two of the sides are congruent, which also means, I'll try to draw one here really quick. So like these two sides would be congruent, right? And that also, you'll end up finding here very shortly, that also means that the opposite angles of those sides are also congruent. Okay, so that's an isosceles triangle. So the parts of an isosceles triangle, this isn't super important, but I wanted to give this to you, that these sides are, the congruent sides are called legs. Okay, and then the vertex angle is always the angle that's in between the legs, which would be 1 in this case. And then the base angles are the two angles that are formed by the base and the legs, so 2 and 3 in this case. Okay, so maybe just jot that down in your notes. Make sure you know what the pieces are in case they ask you for one of those. But let's just keep cruising. So the isosceles triangle theorem, this is one of the big takeaways for today, states that if two sides of a triangle are congruent, then the angles opposite of those sides must be congruent. So in this case, I already said this earlier, but in this case, if my legs were AC and BC here and they were congruent, then the opposite angles from those side lengths are also congruent. So angle 1 is congruent to angle 2. Again, this is only true if this is an isosceles triangle where those two things are congruent. Okay, the converse says that if you have two congruent angles, that the opposite side lengths then have to be congruent. So it just works in both directions is all this is saying. So again, pause the video if you need to get this in your notes, but I'm going to keep cruising. Example 1 says, in the picture that's here in the right hand corner of your screen, says name two unmarked congruent angles. Well, we have two angles that are congruent that are marked. That would be, G here, this guy, and J. Those are congruent. But they're saying to name two that are not marked. Okay, so to do this, I'm going to use my isosceles triangle theorem and its converse. For this particular one, it'll be the isosceles triangle theorem. And in looking at this, I see that I have these two side lengths here that are congruent. So on this triangle that I have highlighted here, what I know about that is that since those are congruent side lengths, their opposite angles must be congruent. So that would be these two, and you have to be very careful. You can't just name that G and J, because you can see here that G and J actually relate to two different angles. So you have to be very careful. We're going to call this angle FGJ is congruent to angle FJG. Okay. Notice that the middle ones are the ones that we're really talking about, the J and the G. Okay, but you have to use all three letters so that you know that we're talking about this part of the G angle and not the other part. Okay, I'm going to erase the highlighting on here so I can now talk about the second part of this question. 1B says, name two unmarked congruent sides. Well, that means I have to know something about the angles opposite of those sides. And the only thing that I know here is that this angle is congruent to this angle. So now I'm going to use the converse and show on this triangle here. So again, looking at the other triangle, right? So on this triangle, opposite of this angle is congruent with opposite of this angle. Okay, so that we would say that GH is congruent to JH. Okay, and I know that because of the converse of isosceles triangle theorem. Since the two angles are congruent, the opposite side lengths have to be congruent on that big triangle. Okay, so let's keep cruising here. The equilateral triangles. Equilateral just means equal side length and equal angles. Okay, so that's what these two theorems are saying, is that if a triangle is equilateral, then it's also equal angular. Okay, so that's what this is saying. And it turns out, just highlighting the 60 here, that the only way to get three angles to be the exact same size, right, or to get an equilateral triangle is if they're all 60 degrees. Okay, if they're all going to be the same, you have to take 180 degrees, which is the total in a triangle, divide that by 3, and you get 60. So if you see a 60, 60, 60, you know that that is an equilateral triangle. All right. So make sure you get that all in your notes, and then let's go on to example 2 and 3 here, and then we'll be done, and you guys will be on to your homework. So here it says find the measure of angle M. Okay, notice that we know that this angle, the vertex angle, is 120, and that we don't know the base angles, but we do know that they're the same. So altogether we have 180 degrees. We subtract our vertex angle. We're left with 60 degrees to work with. That 60 has to be split up evenly between that guy and that guy. So if we take 60 and divide it by 2, we know that the measure of angle M must be 30, because 60 divided by 2 is 30 degrees. Okay, so we can label that as 30, this is 30, right? And then that would all add up. For part 2b, it says find PN. Okay, well, let's erase this so we don't have to look at all of this here now. Okay, and then for PN, we're looking for this, right? What is this length? Well, opposite of this congruent angle, we know that the side opposite is 11 centimeters, so opposite of this, the other congruent piece of that, would also have to be 11, right? So 11 centimeters, just using our rules, pretty straightforward. Last example, example 3. Okay, it says find the missing values here. Okay, this looks like to be an isosceles triangle. Since we know those two are the same, we know that these angles must be the same. So I know that about this. Since those are the same exact side length, then I know that this piece must equal this piece, right? So I'm going to just set those to equal each other. 4y minus 2 has to equal 2y plus 2 because they are congruent. And then let's just solve for y. So let's subtract 2y from both sides. And at the same time here, we can add 2 to both sides. Okay, this goes away. This goes away. 4 minus 2 is 2y. 2 plus 2 is 4. Divide both sides by 2. Y is equal to 2. Okay, so I found that y is equal to 2. And then for the other piece here, we know since this is 80, and there's 180 degrees in a triangle, we know that since this guy is across from this guy, that these have to be congruent angles. So we're going to take 180, we're going to subtract the vertex angle of 80. We have 100 degrees left to work with. We have to split it evenly here between the two pieces. So I know that each angle is worth 50 degrees. So this has to be 50, and this has to be equal to 50. So to solve for x there, I guess I'll do it down here. I'll take 6x plus 8, set it to equal 50, and then solve, right? So I have 6x is equal to 42 if I subtract 8 from both sides. So then x is equal to 7 when I divide by 6 to solve for x. Okay, so x is equal to 7, y is equal to 2. That's it for the examples. I didn't really do an example related to an equilateral, which I'm kind of disappointed about, but it's pretty straightforward when you run into that in the homework. Okay, so 4.6, I believe I have a homework sheet posted on Classroom. If not, here's your assignment, and we'll catch you guys next time.